You have one share of stock A and you want to hedge it by shorting stock B. How many shares of B should you short to minimize the variance of hedged position? Assume that the returns of correlation is R. Now this problem would require the use of variance and covariance formula. So in case you're not familiar, I'd suggest you look it up once before proceeding. Let's assume that the returns of stock A is given by RA, returns of stock B is given by RB, and their correlation is R. Variance of RA is given by var RA and variance of RB is given by var RB. Let's say we short H shares of stock B to hedge the position. We now have one share of stock A whose return is RA and H shorted shares of stock B whose return is RB in our portfolio. So the return of our portfolio is given by RA minus H times RB. Negative because we have shorted stock B. And the variance of this return is given by var RA minus H times RB. Now recall that if we have two random variables A and B, then the variance of A plus B is given by variance of A plus variance of B plus 2 times the covariance of A, B. And the correlation between A and B is given by the covariance divided by the product of standard deviations. So we can write the covariance in terms of correlation R multiplied by the standard deviation of A into standard deviation of B, where the standard deviation is just the square root of the variance. Also, for constant m and a random variable x, we have the variance of m times the random variable x equal to m squared times the variance of x. And in case of covariance, a constant times the random variable is equal to m times covariance of x and the other random variable, whether it's x or y or any other random variable. So using these two results in our portfolio, using the above two results in our portfolio variance R, we get this following expression: variance of RA plus H squared times variance of RB minus twice the covariance of RA and H times RB. Now we can replace the covariance of in terms of the correlation R. So this becomes R times the standard deviation of RA into standard deviation of H times RB. And further we can simplify it by writing the standard deviations in terms of the square root of the variance. So we now have an expression of the portfolio variance in terms of the variance of the returns, the correlation, and H. Now to minimize this, we differentiate with respect to H and equate it to 0. So differentiating the portfolio variance via R with respect to H, we get this following expression, and when we equate it to 0, we can solve it to get the optimum value of H, which is given by the correlation times the square root of ratio of the variance of the returns.